The maximum afternoon temperature T in degrees Fahrenheit in a given city might be modeled by T equals 60 minus 30 times cosine of x pi over 6, where x represents the month, with x equaling 0 corresponding to January, and x equaling 1 to February, and so on. Find the maximum afternoon temperature for January and for April. Pause the video while you work on this problem, and when you're finished, restart the video to check your solution. Welcome back. Let's see how you did on that problem. First thing I want to do is write down the equation that T equals 60 minus 30 times cosine of x pi over 6. We want January, which is the equivalent to x equals 0. So I plug in 0 for my x value. So I get T equals 60 minus 30 times the cosine of 0 times pi over 6. But 0 times pi over 6, of course, is 0. The cosine of 0, all right, cosine of 0 means that we want the x value when there is a angle of 0, which, of course, that's the point 1 comma 0 on the unit circle, so the cosine is equal to 1. So this is just 60 minus 30 times 1, which of course is 30. Well, what does that mean? That means that in the month of January, we're looking at 30 degrees Fahrenheit. Okay, the other half of the problem was April. Well, what does April refer to? April would in this case be x equaling 3. And so we plug in x equals 3 to the equation. So T equals 60 minus 30 times cosine 3 pi over 6, which of course reduces to pi over 2. Now, pi over 2, when you do it on the unit circle, is along the y-axis. So that point would be 0 comma 1. So the cosine of, in this case, pi over 2, the x value is 0. So therefore, T is equal to 60 minus 30 times 0, which of course then is equal to 60. And what does that mean then? It means that the maximum temperature for the month of April would be 60 degrees Fahrenheit. You did a lot of great work in today's lesson. Now, be sure that you work all of the exercises that your teacher assigns, because you'll find the problems both interesting and fun to solve. We'll see you next time.